Too little or too much iron can be detrimental to your health. I'm Dr. John Bartemus, and I'm putting the pieces together to help you live a life at optimal. Today, I want to dive into a couple of the important pathways that iron is key in physiology and how it impacts your health. So let's dive in. Iron, first of all, is very important because it carries oxygen. So in carrying oxygen, the oxygen is carried by iron on hemoglobin to the cells to be used in the mitochondria to produce energy. Oxygen is also key in playing a role in the Fenton reaction. Iron catalyzes the Fenton reaction, which uses reactive oxygen species to defeat pathogens and also damage tissue. Now, the purpose of the Fenton reaction isn't to damage tissue, but tissue damage is a side effect of reactive oxygen species or free radical production. Free radical production is normal to an extent as a byproduct of the electron transport chain in energy formation in the mitochondria, and then reactive oxygen species are also used by our white blood cells as a way to attack and kill pathogens. Iron is also key as a necessary cofactor for the production of every single neurotransmitter in our body. So dopamine, serotonin, epinephrine, norepinephrine, GABA, all of these require iron to be formed. And so, as you know, serotonin and dopamine, all of these play a role in mood and in cognitive performance. So focus, concentration, paying attention, all the traits that we require to function at work and get things done, or to perform out on the athletic arena and get things done. And so if we have too little iron, these things can all be affected. Too little iron will cause a decrease in energy because we're not carrying oxygen to the mitochondria to produce ATP or energy. Too little iron will result in suboptimal Fenton reaction catalysis, which then will result in suboptimal reactive oxygen species production and suboptimal immune attack against pathogens. So it may make us more prone to infection. Too little iron will result potentially in low neurotransmitter levels, which then can contribute to anxiety, depression, inattention, lack of focus or concentration. So maybe ADD or ADHD, and many of the neurocognitive or mood disorders. If we have too much iron, then we can have too much Fenton reaction going on, which results in too much reactive oxygen species production, which can result in too much tissue damage. And too much tissue damage is seen in iron overload, and the end or extreme end of iron overload disease is known as hemochromatosis. And so people with hemochromatosis have high levels of reactive oxygen species, which cause high levels of tissue damage and shorten the lifespan to 60 or less if not managed properly. So this is just a primer on iron physiology. These are only a couple of the pathways that it functions in. It functions in all kinds of areas in our physiology. But we want to remember that low iron isn't the only bad thing. High iron is also bad. We want to have optimal levels of iron so that energy levels are optimal, immune function, especially against infection, is optimal, and neurocognitive function or mood and performance are optimal. So working with a practitioner that knows how to evaluate and assess iron status through laboratory work is of prime importance, because they can run the labs, figure out where you are on the spectrum, and help you dial it into optimal if necessary.